Alright, here are the video notes for lesson 1.10, mathematical modeling and variation. We just really focus on variation because we're not tested on the modeling aspect. And so I am going to skip right ahead to the first variation, which is direct variation, which usually is in this form y equals k times x. And so you're going to notice that y varies directly as x, or y is directly proportional to x. And so those are kind of the keywords we're going to be looking for in these problems to know its direct variation and to know what our y and x are going to be. All right, and then we follow these three steps here to actually solve the problem. And so when we look at a first problem like we see here, it says in Pennsylvania the state income tax is directly proportional to the gross income, which means the state income tax is our y, and the gross income is going to be our x, because the y needs to be directly proportional to x. Y needs to be directly proportional to x, and so that's where I'm choosing that from. And then it says, in Pennsylvania, your state income tax deduction is $46.05, and so that's going to be my y, because that's my state income tax, and that's what we said y was going to be. For a gross monthly income of $1,500, well, gross income was our x, and so $1,500 is going to be our x. Now we need to set up a mathematical model to actually solve it, and so we need y equals k times x, and the first step is to plug things in, set up an equation, and find k. And so we got to plug our y in, which is 46.05. K is k, because we need to solve for it, and then that's going to be multiplied by 1,500. Oops, not 15,000. 1,500. Okay, divide both sides by 1,500. And we're going to have our k, which I got to grab my calculator quick. After using my calculator, I got that k equals 0.0307. And then to set up my equation, because that's all it wants me to do is set up a mathematical model, I just have to use my direct variation, where I'm going to leave y as y. I'm going to now plug in k, which is 0.0307, and I'm going to leave x as x, and that would be my mathematical model for the direct variation using the numbers that they give me and the situation they give me. Okay, so that's the first type, is direct variation. The next one we're going to do is direct variation, but we're going to have some kind of nth power, some kind of power to it. These problems are going to have the form y equals kx to the n, so it's similar to direct variation, but we're going to have that nth power. And you'll still see these similar words, varies directly proportional, but you're also going to see some kind of squaring, cubing in the written directions. And so a good example, the distance a ball rolls down an inclined plane is directly proportional. So again, you know it's going to be some kind of k times x to the square of the time it rolls. And so there it tells me it's going to be the direct variation, but with the nth power, because it's going to be squared of the time it rolls. So during the first second, the ball rolls 8 feet. And so we're going to use all this information. So remember, it's y equals k times x to the nth power. Here we're going to have distance equals our k times, the thing that's going to be changing is the time. So distance is dependent on the time, and the time is going to be squared because it says the squaring of the time it rolls. Okay, so distance is the y because it's dependent on the time, and then time is getting squared. Okay, now to fill in some of these other things, distance we would be able to solve for. K we need to know, so let's see what I can do. If I put 1 second in, so if I get d equals k, if I put in 1 second for my time, I know that I should get out 8 feet, because it says right here during the first second the ball rolls 8 feet, so 1 squared is 1, 1 times k is k, and 8 would stay 8. And so that means 8 is my k. And I can set up my equation to use for part B, being that y equals 8 times t squared. And I can now find any kind of time duration for this problem. So I can do y is what I'm looking for. 8 is 8. We're trying to figure out after 3 seconds. So 3 seconds is my time. I square it. and I end up getting y equals 8 times 9. And when I solve it here, I get a final answer of 72 feet, I believe we're talking about, right? Yes, it's in feet, so 72 feet it rolls after that 3 seconds. Okay, again, the thing that's tricky is being able to read the problem and taking out what you need to take out. The next one is inverse variation, so you can see you'll hear different words, varies inversely, inversely proportional, and then we're going to use this equation here. Still same thing, we solve for k first, and then we plug in our x. We know what our x and our y is. We should know what our power is. We solve for k, and then that k is going to be how we set up the modeled equation. We also have the combined variation, and so this is going to be one where we have multiple on here. Let me see if I have it in a different one. No, it's here. And so the two different ways we could do this is now we're going to add a third variable because we're combining inverse and direct variation. And so we're going to have k times y divided by x, or what we could have is z equals k times x divided by y. Both times the z is what we're solving for, and the x and the y here are just the two things that got flipped. We have a couple examples here to see when to use inverse variation, when to use combined variation, and then we'll have one more, which will be our joint variation that we'll get to. So the first thing here, this gas law states that the volume of an enclosed gas varies directly as the temperature and inversely as the pressure. Okay, so we have a lot going on here. The pressure of the gas is 0.75 kilograms per square centimeter when the temperature is 294 Kelvin and the volume is 8,000 cubic centimeters. What we have is volume. Volume directly varies as temperature. So the K directly varies with temperature, but it inversely varies with pressure. And so that's why I'm going to have T on top, because K times T is the direct variation, and then P is on the bottom because the division is the inverse, what's happening there. And so what I can do then is I just need to pick and choose temperature and pressure. So my pressure is 0.75, so that's what I'm going to plug in for P. Temperature is 294 Kelvin, and my volume is 8,000 cubic centimeters. So what I have is 8,000, because again I need to solve for K. K times my temperature, which is 294 Kelvin, all over this 0.75. Okay. Now I'm just going to use my calculator and solve for K. After I do that, I got K equals 20.41. And then I can set up my equation being volume equals 20.41 times the temperature divided by the pressure. And so it's saying we need to find the pressure when the temperature is 300 Kelvin and the volume is 700 cubic centimeters. So we know the volume, which is 7,000. We know 20.41. We know the temperature is 300 Kelvin, and then we're looking for pressure. Okay, again, I'm just going to use my calculator here and solve for P. After I calculate it out, I have P equaling 0.87, and that would be in the same pressure as they were before, which was kilograms per square centimeter. So kilo per square centimeter. Okay, so again, just reading these directions, when I give away homework problems and you read them and you have questions, please let me know. Or when we go through the test review and we're looking at a problem like this, just let me know, like, which one is this? I'm confused by the wording, and the more we read them, the better we are at picking out what we need. So the last one is joint variation, where it's again 3 variables, z, x, and y. But this time it would just be 2 direct variations, so it's just 2 multiplyings. Or you'll see this a lot, z is jointly proportional, or z varies jointly of x and y. And that word jointly is going to mean all multiplication. So we don't have that combination. We don't have that inverse on here. So a good one. The simple interest for a certain savings account, jointly proportional. So we know it's going to be z equals k times x times y. And that's going to be jointly proportional to the time and the principal. So interest is the big one, is like the z, and then it's going to vary jointly to those 2 things. after 1 quarter, 3 months, the interest on a principal of $5,000 is $43. And so we're going to pick out what we need, and then we're going to solve for K, and we're going to figure out how much interest is after that 3 quarters. So what I'll have is the interest is the thing that's kind of varying jointly here, and it's varying. So K is what's going to vary it. And then we have time and principal here. And we have an interest on the principal. So plugging things in, my interest was $43.75. The time was 3 months or 1 quarter of a year. So the way I'm going to show that, K is still K. A quarter of a year is going to be 0.25. And then we will have the initial principal of $5,000. Okay. Again, I'm going to pause and solve for K here. After solving for K, I got K equals 0.035. So now I can use that to figure out the interest after 3 quarters. And so I is what I'm looking for. It's the interest. K is going to be 0.035. Time is 3 quarters. So if 1 quarter is 0.25, 3 quarters is 0.75. And then my interest, or my original principal is still $5,000. And we can see how much interest I'm about to make over that 3 quarters. After getting interrupted and calculating out what my interest is by just multiplying everything, I got that the interest would be $131.25. And that would be my final answer there. Again, I have my homework on here, but I'll post the updated homework if it's not already posted. And again, please ask me questions reading these problems. It's, again, just more about picking and choosing the correct thing, which can be difficult. So please ask me questions, and we'll have time for questions and stuff on the practiced exam posted Wednesday.